Good day, students. I am Dr. Monika Khetarpal. I am Associate Professor of Physics in Government Dungar College, Bikaner. Today I will deliver my lecture on Classical Mechanics, which is a paper of MSc Previous Physics. In my previous lectures, I have taught you about constraints. Constraints means restriction. By imposing a constraint on a system, a mathematical problem simplifies. For example, if I take a free particle, for a free particle, I need 3 Cartesian coordinates. But if I restrict the particle to move along a single direction, then I will be in need of only 1 coordinate. So imposing constraint simplify our problem. But this introduces 2 types of difficulties, which we have resolved in our D'Alembert principle and Lagrangian equation. First difficulty was that constraints introduces equation so that coordinates are dependent on each other. To remove this difficulty, generalized coordinates was introduced, and another difficulty was that force of constraints, they were not given any importance in constraints. Later, D'Alembert formulated mathematics in such a way that force of constraints do not appear in picture. So using D'Alembert principle and generalized coordinates, Lagrange's equation was derived, which I have dealt in my last lecture. Lagrangian equation is d by dt, that means derivative with respect to time, del t upon del qj naught minus del t upon del qj is equal to capital Qj. Here capital T is the kinetic energy of n particle system. Small qj means generalized coordinates. These generalized coordinates are independent coordinates, and capital Qj is the generalized force, and this generalized force is summation Fi dot del Ri by del Qj. And Qj dot is the derivative of generalized coordinate with respect to time. There are n such equations because there are n generalized coordinates, and Lagrangian equation, they are second order differential equation. Now, what I am going to do, firstly, I am going to derive the Lagrangian equation for conservative system, and secondly, I will derive it for non-conservative system. So considering my first case, for a conservative system, we know that forces are derivable from potential energy. For example, for ith particle, acting force is Fi, then Fi can be expressed as minus del I V, V being the potential energy. So writing del I, which means the derivative of V with respect to Ri. Ri means the position of ith particle from origin. So I have force to be equal to minus del V upon del Ri. Putting this value in generalized force, which was Qj is equal to summation Fi del Ri upon del Qj, I got minus del V upon del Ri upon del Qj. Del Ri here cancels out. So I get the value capital Qj is equal to minus del V upon del Qj. The general form of Lagrangian equation is d by dt del t upon del Qj dot minus del t by del Qj is equal to capital Qj. I have determined the value of generalized force, substituting generalized force to be minus del V upon del Qj. I got this equation. Now I am collecting the similar type of terms, that is del by del Qj. These two terms I am putting them in a single bracket. So I obtain the equation del, this is the term, del T minus V upon del by del Qj. Now in this first term, I have written one extra term. What is that term? Del V by del Qj dot. As the system is conservative, I have already stated that system is conservative in nature. We know that when system is conservative in nature, potential energy will depend only on coordinates. It will not depend on velocity. That means potential energy derivative with respect to velocity, that means Qj dot, will be 0. So writing this expression as, which earlier was d by dt del T by del Qj dot, as del T minus V, it will create no change because del V by del Qj dot is simply equal to 0. Now, in this expression, I am writing T minus V to be equal to L. And what is L? L is termed as Lagrangian of the system. So I got the equation d by dt del L upon del Qj dot minus del L upon del Qj equal to 0. This is the Lagrangian equation of motion for conservative system. So now I am going to derive the Lagrangian equation of motion for non-conservative system. For a non-conservative system, the potential energy will be a function of coordinate as well as velocity. So the difference between conservative and non-conservative system is that in conservative, potential energy only depends on coordinate, whereas in non-conservative system, potential energy depend on coordinate as well as velocity, which is Qj dot. So I am assuming that generalized force, which is capital Qj, I am supposing it to be of the form minus del U upon del Qj plus d by dt del U upon del Qj dot. As in a non-conservative system, I have found the value of capital Qj and substituted capital Qj in the general form. The same process here I am adopting. I am using the general form and I am putting the value of capital Qj. So substituting the value of capital Qj, I got this expression. Now collecting similar type of terms, that is first term, which is differential with respect to t, and another differential is with respect to small Qj dot. I got the term in the differential, I got t minus u. To differentiate the potential energy between conservative and non-conservative, I am expressing here the potential energy as u. In conservative, I have written potential energy as V. And other two terms are minus del by del Qj, T minus U equal to L. As kinetic energy minus potential energy is Lagrangian, so putting L in spite of T minus U, I got the expression d by dt del L by del Qj dot minus del L by del Qj equal to 0. This is the Lagrangian equation of motion for non-conservative system. This equation is similar as we have derived in our conservative system. But here the difference is that here potential energy is dependent on the particle velocity. I hope students, you must have understood what I taught you today. Now, on the basis of my lectures, I am giving you some questions. First problem here is Coordinates, generalized coordinates. They are, first option is dependent, independent. Third option, spherical polar. Fourth option is definitely not Cartesian coordinate. Second problem is of a rigid body. A rigid body. Constraints in a rigid body, whether they are holonomic, non-holonomic, skeuronomic, or none of these options. And the third problem is I'm taking a particle which is moving on the arc of a sphere, then the generalized coordinates will be r only, theta only, r and theta both, or x and y. Now the fourth problem is I'm taking a rigid body which is moving freely in space. Then its degree of freedom will be, you have to determine the degree of freedom which I have taught you earlier. Options are 3, 4, 6 or 9. So I hope you must do this assignment as early as possible. Thanks students for watching.